Okay, so now we're ready to learn about factorizing square roots. And in order to be able to do that, we have to be very familiar with the first, let's say, 15 squares. So you know that 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. And this list of numbers, 1, 4, 9, 16, 25, 36, and so on, is going to be very important when we are going to factorize square roots. What we're going to do is, when we have a square root and we have a number underneath the square root, we're always going to check if we can simplify this by rewriting it in such a way that we get a smaller number underneath the square root sign, because that just looks nicer and it's simpler, and it's also easier to calculate with if we have a more complicated expression involving more than one square root. So we're going to see if we can change this into an expression where we have a smaller number underneath the square root sign. And in order to do that, we're going to check if we can divide this number, so 20 in this case, if we can divide this number by one of the numbers in this list, so by 1, 4, 9, and so on. So let's see. Well, in this case, that's possible. We can divide 20 by 4. And if we divide 20 by 4, we get 5. So we can rewrite this as the square root of 4 times 5. And we also know now, of course, that the square root of 4 times 5 is just the same as the square root of 4 times the square root of 5. So now we have a multiplication of 2 square roots. Well, that's worse, you would think, but actually we have chosen these numbers in such a way that we can now solve one of these square roots. So we look at the square root of 4 and we see, oh, that's just 2. So actually we can simplify this to 2 times the square root of 5. And whenever we can do that, we try to do so. So because this number is smaller than this one, this counts as a more simplified expression than this one. Another example, square root of 50. Can we simplify this? Well, we can if we can divide 50 by one of the numbers in this list. And we can do that because 50 is divisible by 25, and then we get 2, of course. So we can rewrite this as the square root of 25 times 2, or immediately as the square root of 25 times the square root of 2. And then the square root of 2 is still impossible to simplify, but we can simplify the square root of 25 because that's just 5. So this becomes 5 times the square root of 2. So 90, can we divide this by any of the numbers in our list? Yes, we can. We can divide it by 9. So this becomes the square root of 9 times the square root of 10 is 3 times the square root of 10. And that's it. We can't simplify any further. Square root of 98. 98 is divisible by 49. It's 49 times 2. And 49 is the square of 7. So the square root of 49 is 7. So this simplifies to 7 times the square root of 2. Square root of 80, you could divide this by 4, and then in the end you get the square root of 4 times the square root of 20 is 2 times the square root of 20, and then you'll see that you can do the same again for the square root of 20. So then you can solve this in 2 steps. It's slightly easier if you see immediately that you can divide 80 by 16. So you can rewrite this as 16 times 5. So this is the square root of 16 times the square root of 5, and that's 4 times the square root of 5. And this is the most simplified result. So if you had 2 times the square root of 20, you can still simplify further to 4 times the square root of 5. So one reason we do this, one reason we factorize square roots if we can, is because sometimes that helps us to see that we can actually add or subtract square roots. So sometimes after we simplify them in this way, they turn out to be like after all. So in this example, square root of 20 plus the square root of 5, your first intuition may be to say, okay, so these are not like, so there's no way to simplify this. There's no, this is our final answer. But actually, when we look at this square root of 20, we see that 20 is divisible by 4, which is 2 squared. So I can rewrite this as square root of 4 times the square root of 5, of course, plus the square root of 5. And then I can solve this square root. So this becomes 2 times the square root of 5 plus 1 times the square root of 5 is 3 times the square root of 5. So actually it turned out that we could add these two. And a similar example, square root of 32 plus 2 times the square root of 50. These seem to be unlike, but if we simplify them first, we will see that 32 is actually 16 times 2. And 50 is actually 25 times 2. So let's rewrite this as square root of 16 times the square root of 2 plus 2 times and then square root of 25 times the square root of 2. And now there's 2 square roots here that I can solve, that I can calculate. This becomes 4 and this becomes 5. So I get 4 times the square root of 2 plus 2 times 5 times the square root of 2. 2 times 5 is 10, so this becomes 4 square root 2 plus 10 times the square root of 2 is 14 times the square root of 2. And this is my final answer, of course. Okay, so again we're going to see if we can simplify these first and maybe then after that add them. So 90 is the same as 9 times 10, so we can rewrite this as square root of 9 times square root of 10. 40 is the same as 4 times 10, so this is square root of 4 times the square root of 10. So we get this expression, and then there's 2 square roots here that we can calculate, that we can solve. So we get the square root of 9 is 3 and the square root of 4 is 2. So we have 3 square root 10 plus 2 times the square root of 10 is 5 times the square root of 10. And in the last example here, 72 is the same as 36 times 2. 50 is the same as 25 times 2, so we can rewrite this 2 times square root 36 times square root 2 minus the square root of 25 times the square root of 2. And again, there's 2 square roots here that we can calculate. This becomes 6 and this becomes 5. So 2 times 6 square root 2 minus 5 square root 2. 2 times 6 is 12. So we get 12 times the square root of 2 minus 5 times the square root of 2. These two terms have like roots because these numbers are the same. So we are allowed to subtract them. So that's 12 of something minus 5 of something is 7 of that thing of the square root of 2.